All right, so lesson number 10 here. We go fancy words here. All right, writing and interpreting inequality statements involving rational numbers. Okay, so rational numbers. We've seen these people. These are they look like our fractions. So they can be whole numbers, they can be decimals, they can be fractions, mixed numbers, all those type of people, because all those people can be written as a fraction. Now, an inequality statement, you've actually seen them, you probably just haven't referred to them. Inequality are your good friends of less than, who looks like that, and then also your other good friend of greater than, who looks like that. Well, all right, maybe not like that. Let's try that again. All right. Dun, dun. All right, so the idea here is we read from left to right. So when we read from left to right, maybe the mouth opens towards the larger number, so this side is the smaller, so that's why we read as less than. Again, it just kind of depends. The point always points to the smaller number. However you want to look at it, whatever little of those kind of alliterations or whatever those connections that you want to make here. So let's see here. The amount of money I have in my pocket is less than $5, but it's greater than $4. One possible value for the amount of money in my pocket is, well, as long as you're bigger than 4 and you're smaller than 5. So how about like $4.50? That works. All right. So you could have anyone as low as $4.01. All right, and you could have anyone in between $4.99. All of that would be less than 5. But greater than 4. Now, it can't be 4 because it needs to be greater than that amount there. But it can't be 5 because it has to be less than the 5. So that's why we're looking at these particular amounts. So when we use our inequality statements, right, inequality comparing the possible values of money in my pocket to $4. Okay, so comparing it to $4. So I said $4.50, so we're going to use that there. So if I'm using, all right, the $4.50 and I'm comparing it to the $4, you would say $4.50 is, yeah, here we go, hey, greater than. We remember these guys. And then if we're going to compare it the other way, $4.50, and we're going to compare it to the $5, the inequality that we would use is, $4.50 is less than the $5 that we are after. Okay, so graph your answer. All right, example 1 on the number line. So from part A. So the whole idea here is let's get a 0 that's in between there. All right. In fact, you know what? Let's not go in between because we know that we're going to be dealing with positive numbers. I'm going to start with a 0 right there. So a 1, a 2, a 3, a 4, a 5, and a 6, and I'll stop right there. So from part A, all right, graph your answer from example 1, part A on the number line. So part A was come up with a number that would use. So I chose $4.50. So that's right in between there. All right. And then what we're looking at is, anytime that circle appears, I don't know if you see the circle. Let's see here. Let's see, she's a whole bunch of dots. There we go. All right. Graph your answer from a number line. Okay, I've done that. Graph the points associated with 4 and 5 on the number line. So with 4, all right, we're looking at that. With 5, we're looking at that. Oh, no, we're not looking at that. Uh-oh. Whoops. All right, we're back. So with 4, we're looking at that, and then with 5, we're looking at that. So the whole idea here is that you can see that it is someone that's in between it. Now, one of the things that we're going to look at, though, graph your answer in part A. Okay, graph the points associated with 4 and 5 on the number line. Okay, we've done that. Write one equality statement that shows relationship among all 3 numbers. Okay, so what we need here is we know we've got a 4. We know we've got a $4.50, and we know we've got a 5 that's involved here. So 4 is less than $4.50. Now, what we kind of want to do here now is we're going to look at these particular ones. So we're going to pretty much cover this up. So we're going to pretend that it's not there. All right. So kind of almost like take your hand, put on the screen, and cover up the 4, cover up the less than symbol. And we're just looking at this. And we say, read this, we would say $4.50 is less than 5. So at first, we're just writing inequality statement for these two. Okay, and then, all right, we're only looking at these 2 particular ones, and then that's how we can write it using all 3 of them that we've got. So this is what we're after here, all right, being able to write one inequality statement that shows relationship among all 3 particular numbers. that's kind of your your new part if you want to think about it from that standpoint. Okay, so here we go. Write one inequality statement to show the relationship for following shoe size. Following shoe size. All right. Yeah, 10.5, 8, and 9. So if you notice, we've already got them in order from least to greatest. So again, we're just looking at the first two, 8 and 9. 8 is less than 9, and then for 9, 9 is less than 10.5. Now, from greatest to least, so there's your 10.5, there's your 9, there's your 8, your inequality. 10.5 is greater than 9, and then 9 is greater than 8. So what we kind of want you to notice here is this, is that when you're from least to greatest, all right, look what you always use. You always use the less thans. All right, it's always less thans. All right, so if you want from least to greatest, it's always going to be your less thans. You want from greatest to least, it's always, all right, going to be your greater than. So do watch for that. And again, that's because of the setup and the patterns that come along here. So let's see what we got here. Mary compared the rainfalls for May, June, and July. All right, so there we go. This year's, last year's, change. Okay, so write inequalities that order the changes in total rainfall. Okay, changes there. All right, so from least to greatest. So first of all is, okay, negative number. You have to be the smallest amount. And then 3/10 and 5/10. So hey, look at that. It kind of was it was in order already. Now, because we went from least to greatest, I know right away I can just put my less than symbols in. All right. Now, again, I can just look at these two and say this number is less than 3/10, and I can say this number is less than 5/10. But again, if I know my pattern, all right, so there's my 5/10, my 3/10, my negative 1 and 4/10, and I got greatest to least, I always know we're going to have a greater than symbol. All right. So does the greatest number indicate the greatest change in rainfall? Oh, okay. Well, wait. Which number did have the greatest change? Well, it was the negative 1 and 4/10 had the biggest changed. All right, the biggest change. All right, but it is the smallest number. So yeah, that's what we got to watch for. Negative is smaller than a positive, but again, change isn't always about simply the biggest number. It's again who moved the most. All right, what changed? So that could be a negative amount. It can definitely drop there. So let's see what we got going on here. Mark's favorite football team lost 2 yards on 2 plays back to back. All right, they lost 3 yards on the first play. All right. Ooh, they lost 1 yard on the second play. All right. Ooh, write an inequality statement using integers to compare the progress made on each play. Okay, so the first thing is they lost yards on 2 plays. Okay, so they lost 3 yards, lost 3 yards, lost 3, integer. Yeah, negative 3. All right, and then they lost 1 yard on the second play. Okay, so they lost 1 there. Write an inequality statement using integers to compare the progress made on each play. So here we would say negative 3 would be greater than, is it? Greater than? No. Negative 3 is further to the left on the number line. That is smaller. So negative 3 is less than negative 1. All right. That's kind of what we want here. All right. Be able to put the integer and then put your inequality statement in there. Sierra had to pay the school for 2 textbooks that she lost. One textbook costs $55. All right. The other costs $75. Her mother wrote 2 separate checks for each expense. Write 2 integers that represent the change to her mother's checking. Okay. So it's not 2 integers to the change in checking account. So if you're writing a check, that is taking money out of your account. So that's the one integer. And that would be the other, because again, it's taking it away. Then write an inequality statement that shows relationship. So negative 55 is greater than negative 75. Now again, if you need to number line wise there, all right, we know this is 0. We'd come across negative 50, and over here we'd come across negative 70. So again, further to the left makes it the smaller number. So this is my smaller number that's there. All right. If you wrote it the other way, if you would do the negative 75 first, then we would need to say that is less than negative 55. So notice when you flip sides, what happened to the inequality? Yeah. So check this out. If you did it over here and you flip sides, negative 1 is greater than -3. And again, if you went number line wise there, all right, 0, -1, -2, -3, it is further to the right. That makes it the larger number. -3 is further to the left. That makes it the smaller number that we're looking at. All right. Let's see what we want to go along. Then we can move on down for there. Something for there. Oh, there we go. All right, people. There's your inequalities. We'll work on this more in class. But for now, all right, we're done.